Hello, everybody. Welcome to the community meeting for ACP-99, which proposes a new standard of validator management. I'm going to let Gautier introduce the differences between his validator manager proposal and the existing standard implementation that the platform engineering team has designed. But first, we'll have a presentation of the design overview, the motivation for the ACP, and then we'll open the floor up for discussion. So go ahead, Gautier.
Yep. Thanks for having me, and happy to share more about ACP-99. And first of all, so when I started this, I think that there was nothing public yet, or at least very little public about how you guys were going to implement this on your side. So I think that there are some kind of legacy architecture that is in this ACP. And as you said, yeah, Megan, I think it's interesting to talk about this ACP in comparison to what has been done by the platform team. And so yeah, overall, the goal was to propose a standard for as well as an architecture allowing to have a flexible way to move from one security model to another. And the way that I did that was having multiple contracts. One that maybe I can share my screen if it makes sense.
Go right ahead. Yep.
Yeah, it moves.
We can see it. Yep.
Yeah. Okay, perfect. So maybe we can start at the bottom actually. So this is basically how, on the overall architectural side of things, this would work. Oops. This is hiding that hell of it, but I can expand this. Yeah. So basically, having kind of a very simple ACP manager contract that Validator Manager that does the very minimal work, all the very basic functionalities like initiating validator registration, ending validator registration, changing the weight of a validator, and handle the sending of fork messaging to the generation of fork messages that would then be sent to the P chain via relayers, and then also being able to interpret the messages signed by the P chain when the validator is added or removed, etc. on the P chain side. And then on top of this, have other security modules, as I call them, that would be deployed in parallel and have communicate with the ACP manager base contract to trigger changes. And in this case, the POA module would be very simple as well, but basically be owned by multisig. And people from this POA module can add and remove validators basically. And then you can imagine other security modules as well, POS. On our side, for those who don't know, so we're building Suzaku, which is a risk-taking protocol, which would have more complex security modules including dual staking and other security modules there. But this is kind of the overall architecture, and then the ACP proposes as well the interfaces for the Validator Manager contract, this base contract. And if we compare this to on the right side here, what Avalabs has done. So the approach is different in this case. So platform team, teleport team actually. I don't know. It maybe it's the same team on the side. On the teleporter contract, on teleporter repository, you have basically one contract that inherits the Validator Manager and either the POS Validator Manager or POI Validator Manager. And if you choose the POS route, you can then use ERC20 staking manager or native staking manager. So I think if we compare to both approaches, I think the main thing is here is like the upgradability approach on teleporter contract. I think it has benefits, because I think when I created mine, I was not sure if we were going to be able to change from the P chain the contract after the initial convert L1. I think it was possible at some time to do it, to change it. Now it's not anymore. So upgradability makes more sense now because of this. At least until we allow people to change maybe the location of this contract to other chains or their addresses. So this is definitely a good point for this implementation. Then there is also a different that I don't have on my side, which is the churn control mechanism. So maybe we can also discuss like what are the benefits of this churn control mechanism? Like, is it needed for like security reasons on the protocol side? And there was also some questions about historical information tracking. I think, if I'm not mistaken, that now it's some kind of historical tracking on the other side as well about past validations. Maybe I'm wrong on this. But basically, in my contract, in this proposal, all the past validations would be stored in there, and the validation, the way the validations are stored is also a bit different, in which on the left on the ACP-99 proposal, there is a validation is basically a status and a node ID, and then a bunch of periods. Each of the period has the wait, the start time, the end time, and the uptime seconds that this validator had during this period. Whereas I think it's done differently on the teleporter implementation of things, where I think you don't store all these periods. You just store the start wait and the current wait. But you can, I guess, the teleporter team can also jump in there and I guess we can like discuss those different points, like what makes more sense and why one implementation is better than the other, but or like more preferable right now. And I have to say that I have basically started to mingle the two implementation together on my side. The first reason is because, well, Avalanche also have the Avalanche CLI, which is now compatible with the right side implementation. And so for example, we want people to be able to use the CLI to add POA validators as well using our implementation. So basically, what I'm doing right now is using this this Validator Manager as the base as well, and kind of implementing this model with where you can plug in different security modules. This was also kind of my idea, because we would like to allow people to kind of mix different strategies together. It's also maybe something we can discuss, like, because our one of our beliefs is that it's going to be maybe a bit dangerous to kind of, for POA, so like L1, to transition to POS in one like go, like it at one particular date. And what we want to try to do is basically allow to transition. For example, let's say you open up 15% of the weight of your L1 to POS while keeping the rest in POA. And basically right now we are developing this this contract that would allow to mix and match different security modules together as you kind of figure out how things are going.
Okay, great. So I think unless anyone else has any pressing questions, I was first going to ask specifically. So
Actually,
I think
go Just before any questions, just want to say this is, I'm pretty sure, the first community-led community call for an ACP. So shout out to you and your team. I think it's huge for the whole Avalanche. So, yeah, thanks a bunch.
Yeah, absolutely. Thanks for bringing that up, Michael. I meant to also mention that this is the first merged proposal from a community member outside of the platform team, and we're very happy. And it's extremely thorough proposal as well, like clearly very well thought out. So, so my first question was the intention behind having the validator manager, like the ACP-99 structs, deployed at a permanent address and immutable address, and then having security modules that can be updated, was so that this would provide security for the actual management of the validation. But who controls the update of the security modules? And if it's also still just like the owner of the original L1, like the L1 creator, then how do you intend for that to be protected in the case that the chain is some sort of like proof of stake or delegated proof of stake from being updated by the original owner? Can that security module function only be called once, or is it able to be called like an unlimited number of times?
Not sure. So first of all, like on the owner, so you mean the ACP-99 ownership, first of all. Yeah, that's a good.
Yeah, exactly. So like we're like deploying this immutable contract at this address that will always be the owner. And that's because this approach was different from having like a proxy contract implementation, separating like the rewards and staking logic from just the validator management logic. But what's protecting that second function that actually sets the security module from, being exploited, I guess, is my question.
Yeah. Well, nothing really, I guess, but you kind of have the same problem, if I'm not mistaken, on the teleporter implementation, until you're like, well, until you kind of revoke or like you kind of throw away the proxy admin key. There is always someone that has the right to upgrade, I would say, the Validator Manager contract to something else. I think once you've reached the state of full permissionlessness, you can just throw away the key. I guess, but I guess until you're there, I don't think there is any solutions against losing control of this address. Like it has to be managed by the L1 team, of course, and through a multisig. But yeah. Correct me if I'm wrong, but I think on the teleporter, on the right side as well, like on the teleporter implementation, it's also the case that there is this proxy admin that can upgrade the contract.
Just to elaborate a little bit on that, let me introduce myself. I'm a developer on the platform team. We've also developed a set of governance contracts that are gated by warp messages signed by the L1 itself. So in some of our end flows, or like an envisioned flow of upgrading from POA to POS to eventually ditching the proxy admin key, would be to hand off that, multi-sig, whatever that admin key might be, off to an instance of this governance contract that is only actionable via a mechanism called off-chain warp messages, which essentially need to be explicitly provided in the validator's configs in order for any action to take place. So initiating once control is transferred over to that set of contracts, the only way to upgrade the contract would be to have the validators themselves approve that message directly in their configuration, their node configuration.
teleporter upgradable contract. Yeah, makes sense. It makes a lot of sense. I think it's well, that's the best way to do it, I guess. Yeah. Once you have a decentralized validator set, makes sense. Yeah.
So one I think similar question that we've been trying to work through a little bit is how we could set something up like a validator manager that's, say, 50% proof of authority, K of N, multisig, and 50% proof of stake, where the difficulty of it is that, as the proof, the proof of authority validators will have certain arbitrary weights, and you'd want those weights to always be 50% of the total weight, but then the weight of the proof of stake portion is variable depending on how many tokens are staked, of course. And curious if I think you mentioned a kind of staking model.
Basically, I guess the way we're looking at it is basically we're kind of assuming that on the PO, for example, if you mix POA and POS, like that on the POA side, you're basically gonna have, let's say, constant weights, like it's gonna be the same validators that will stay, let's say they have 100 weight total, like or like more, like 1,000 total weight. Each of them has 100 weight, like a weight of 500, and basically they would stay this way. And you can, and then what we say is that you can have up to, for example, a weight of 200 on the POS side, and once you reach this, it's just people cannot join anymore on this side. So it's basically, it's not like a fixed percentage, but it's like up to 20, like 20%. This is not, doesn't work, but like if you had a weight of 100, then you had up to 20% of weight, but it's not like fixed, because of course, if you want to have a fixed percentage for each side, then you have to rebalance weights all over, and I don't think it's feasible.
Gotcha. I think that makes sense. So it's kind of like you have to purchase, the stakers are basically purchasing a fixed number of slots somehow, rather than staking directly.
Also curious, like if you have any, if you see any downside of like doing this way instead of like transitioning in one go, like doing the upgrade from POA to POS. Do you think like any problem doing this smoothly? It's more progressively. Does anyone in this call see any like red flag to doing this? Curious.
Maybe it's a good time to segue into validator churn. I know that was one of the primary questions that you left at the end of your ACP, and I'll let the engineer team, the teleporter team, weigh in on that, why they implemented that in their standard contracts, and maybe why you should or don't have to in yours. Is anybody from teleporter willing to explain the motivation for including validator churn control here?
Anyone want to chime in? I have to take it otherwise.
I'm not really on like the teleporter team, but I can talk on like the consensus side. So if you look back in the original Avalanche paper, there was actually a commentary on churn rate limiting. And basically the premise is that in Snow consensus, you don't necessarily need to know 100% of your validator set, as long as people roughly agree on the population that you're sampling. And so when the validator set is changing on blockchains or L1s, it isn't necessarily agreed for that change to happen atomically. So this isn't something that is like a major concern for the primary network, because like the primary network staking is fairly stable. But for something like a smaller subnet or L1, you can run into issues where it's like, oh, I have like a 3-node like network, and now I add like a massive node, and you can get into really weird situations because you're kind of breaking this churn rate limiting that's documented in the original consensus paper. So I think that was the motivation behind including that into the contracts, is to ensure that there weren't drastic changes to the staking distribution. A very simple example, right, is like, imagine you have a single node that is like 100% of the stake, and it basically is just making decisions. And then you have another node that comes in that's going to now basically swamp that and have significantly higher weight. So it's in effect like 100% stake. The first node may have decided on some new block, and before communicating to the current non-validator that it was decided, that non-validator became a validator, like with more stake than that. And so now all of a sudden, like this low-weighted guy is telling you, hey, I accepted this block, but like the new driver of the network is just completely ignoring them at this point because they have so much higher stake. And then they could accept to choose some other block, which in this case is a very kind of trivial safety failure. So what you end up wanting to do is you want to have small incremental changes to your validator set. I forget what the exact like formulation is on like how quickly things can change. I'd have to look back into the paper, probably the teleporter contracts actually, but yeah, that's the rationale.
Yeah, I think also looping back to how to transition from proof of authority to proof of stake and how this applies. The way that we were envisioning it in our implementation was that it would be kind of a full gate opening as far as flipping the switch from proof of authority to proof of stake, with the exception of this churn limit. So say like at the time that you flip the switch, the proof of authority validator set constitutes some total weight, and then you can only add proof of stake validators, that's a percentage of those weights as you go. So there is that, I don't want to say natural, but like a separate mechanism kind of limiting the switch over from one to the other, with the added exception then that when you flip the switch from proof of authority to proof of stake, anybody is allowed to end the proof of authority validators as long as they are still respecting the churn limit. And that's because you don't want, or I guess to move to a fully permissionless system, you can't have validators that didn't put up any stake as the proof of authority validators did. So making it such that anyone can end them removes the requirement for the owner to then later on explicitly end those validation periods. But I don't see any issue in having other implementations of this from a technical perspective. I think it could very well make sense that for an L1, particularly like a high value L1, to not have such a rapid switch just limited by the churn limit, and instead have a more gated transition period where you can still stake and earn rewards, but a certain percentage of the L1's validator weight, total validator weight, is gated behind known semi-trusted nodes, if you will. So yeah, I think kind of even one step higher as far as the ACP is concerned, I would love to see it kind of be able to capture all of these possible use cases. So we don't need like separate ACPs for here's how you do a validator manager where you want this type of transition over this period, and here's how you do a validator manager if it's just proof of stake from the start. I think it's basically already in that vein of allowing any sort of security module to be added, which is great. So
yeah,
we can definitely add on like tutorials about specific cases as we go, but the ACP can still capture the full set of possibilities, or try to at least.
Yeah, thanks. Thanks for the feedback. Yeah, I guess it's also kind of a question of because I do think that right now, even for me, like it makes more sense to at least start from the Validator Manager abstract contract that you guys did as the base for this. And maybe this should be an ACP on its own, because I think you did the same thing with ICTT contracts, that basically you implemented them first and then proposed the ACP for them. So maybe this should be a separate ACP, like or like should the ACP-99 become this just the Validator Manager contract that exists on the table side, or should it become this more like balancer Validator Manager that I mentioned earlier? I don't have any.
Yeah, so I was reading through the ACP yesterday and kind of cross-referencing against our implementation, and I think there's actually a lot of overlap in the current state right now. I think, even just restricting it to two interfaces, the top level module and then the security module, like we could shoehorn that into our implementation, our inheritance-based implementation using like multiple inheritance, for instance. I think the only real pieces that of our implementation that are not compliant with ACP are some of the deployment details, the requirement that the security module be a standalone contract, things like that. But if instead it was reworded to just say, you have to have a system that implements these interfaces, and maybe even some language around how to initiate upgrades, then I don't think we're too far off from having something that, or a standard that covers both potential architectures.
Okay. Yeah. I guess I would have to see how to make this work.
Yeah, one thing that we I think don't have a standard for, I'm not sure what the right word is like what the scope of a best practice ACP is, which we're definitely open to figuring out. On one hand, I think it could just be the interface of like, hey, anything that implements this interface is the best practice for validator managers, but obviously there's a bit more to it than that as far as like the security module considerations and whatnot. So including more information than necessary I think is productive, because teams should think through these things, but at the same time, there could just be one interface that doesn't include the commentary on possible implementations of it. I think would be more like the standard ERC route of like, hey, yeah, the implementation is up to you. This is just the interface. But given that like all of the critical security implications here, I think it makes sense to still include the details that we've both discussed here.
Mm-hmm. Yeah, I agree. Yeah. Okay. Yeah, I think the other thing was, as I mentioned, tracking the periods, but I don't think that like the way you do it on Teleporter on your side is has like a lot of differences. In fact, if it's for distributing words or anything else, I think you can do it with your implementation. So so meaning the fact that on my side I was tracking validation periods separately instead of having also the different ways of lifetime of the validation. One single weight variable that is over time.
Yeah, one thought there, or consideration rather, is ideally we would clean up as much, if not all, state when a validator completely exits. I don't think the implementation in the teleporter repo currently does this. But in order to make them as future-proof as possible, where we could have state rent or state expert, other state size restrictions, keeping around any historic state could become untenable, or certainly much less tenable than it is today, where you just pay for the store once and then it lives there forever.
I guess also you have this on the P chain side, right? The kind of the historical of the validation, or actually I'm not sure if you have all of this information on the P chain side.
Not in the active state. So the active state on the P chain, Steven's probably best to speak to this, but will just be the current validator set, and then the nonce and weight and I think active balance of balances of the active validator sets. But then once a validator ends, they are completely removed from state. So it'd be up to off-chain indexers or ARC nodes on the EVM side to track those types of things for historic queries.
Yeah, makes sense.
What's the use case, Gauthier, that you envisioned for being able to reference those historical validations on chain?
Yeah, at first I was it was about my head the rewards calculation that would be easier if you have kind of a different weight that and time, like the different validation period with all the weight changes of the validator. But I think you guys did it differently, so I don't think it's necessary. But then for the storing the historical state, I guess it's just kind of, let's say, easier to access if you want it for some reason on chain rather than having off chain. But I guess it's not necessary. Could also be like something that you like an extra interface that you extra abstract content that you can inherit if you want to, but you don't have to, like the storing historical validation.
Gotcha. Yeah, from my opinion, when it comes to standardization, is to keep the standardized functionality as kind of minimal as possible. So yeah, I was just curious if there was like a specific use case or flow that was explicitly gated behind being able to access that historical validation on chain.
I think we lost him. I wonder, is it? I maybe shouldn't speak until he comes back. Okay, Gautier's back. You're muted. But I wonder, is there any reason for keeping historical validation information in case the validator decides to rejoin the validation set and then you want to maybe do a rewards calculation based on their total historical performance instead of just the current validation period? Or it doesn't seem like there would be, but I'm interested. Maybe there is some reason for that. You're muted, Gautier.
Yeah, sorry. No, because, well, I think it's quite. It has to be kind of have to do it when before the validator or at the moment that the validator leaves the validator set. I don't think you have to keep the historical state forever.
That's true. Are there any more comments on this topic? Because I did want to ask about the security module implementation. Oh, okay, Ian, go for it.
I guess sort of tangential, but it sounds like we're generally close in terms of implementation standards. So between the two implementations, and I agree with Cam's points that I do think that in terms of potentially making both implementations implement the same standard, it would make sense to make it as minimal as possible. And I think that potentially the tracking on-chain tracking validation periods is sort of tangential or could be an optional interface. But I think one thing that we should decide on is whether a notion of validator churn is critical. So it's definitely interaction with the P chain. It's the security modules that are definitely in scope, or just like defining them safely enough, but broadly enough that there are multiple implementations possible. And then, validator churn, I think, as we discussed, because it potentially leads to easier ways to make
I don't think correct me if I'm wrong, anybody, but I don't think validator churn is actually referenced or like implied at all anywhere in the interfaces, either of the ACP-99 proposal or in our.
It is not, yeah.
So I feel like that can definitely be, a suggestion, but not in the interface definition.
Okay.
Yeah, and as I said, like to be, I'm already using your the abstract contract, so like I can, definitely make the ACP closer to this, and in terms of the security modules, I'm not sure. Basically, the Russian, like in this case, the balancer contract that I was mentioning is implementing, like, is inheriting from the Validator Manager contract of the teleporter side. And this contract then talks to different security modules that, and for these compatibility reasons that I mentioned, for example, the POA security module also implements the POA Validator Manager interface, because then, for example, Avalanche CLI can talk to it. And so you can add, still manage your POA validator set this way without having to do this on your own without any tooling. But I'm not even sure that this should be part of this ACP, and maybe I can do another one for this particular, let's say, flavor of Validator Manager contract, that is the balancer one with the security contract, and we can just keep this ACP around the Validator Manager contract. And so, but it would basically be just about taking what you guys have done in teleporter and kind of replacing this there.
I think that's honestly a pretty reasonable approach, considering, like, of course, the CLI and like the other tooling that the platform team develops is always going to be geared towards supporting the standards that we also develop. So like for the Validator Manager contract and the CLI, as you can tell, like one of the biggest concerns I think that the CLI team really had was, how can we support validator additions and removals for contracts that implement like custom logic, especially in the case of like POS, right? It's not going to be inherently capable if someone's implemented complete custom functionality. But I think separating the actual validator manager logic from the security module, or like the place where the staking logic is implemented, might enable better compatibility. So I think that's a pretty good approach in my opinion. I did want to ask, for the security modules, you had provided a link to the Suzaku contracts library in the ACP. I was wondering if you'd be willing to, share one with us, maybe walk us through it a bit.
Suzaku. Right, so the link is broken. I see now.
It
I
is.
can merge it.
Just
Wasn't gonna say.
that it'd be really cool to see the CLI be able to reference a bunch of different implementations that you get to choose from. We started with the ones that we developed, but that's by no means a technical requirement or what would best serve the users of that tool. So yeah, I think it'd be really cool to see like some easy way for any implementation of these contracts to get like added to the CLI view, maybe through some config that it fetches or whatnot. Yeah, that was a great idea.
Yeah. What? So yeah. So yeah. But so the implementation. Nothing crazy. Maybe you can share my screen as well. But yeah. Yeah. So I. Yeah, so actually, I'm actually reusing, I think, a lot of the teleporter stuff for all the validator messaging part. So I was actually pretty glad that someone did this part when I started implementing this, because yeah, it's not that trivial when you're not on the Avalanche side of things, I'd say. And also, like, things were changing, so I was glad that I could just pick up the latest version of your validator messages like this. And so yeah, I don't think there is nothing like crazy in the implementation there, but maybe this one. So this one, this is the one I did, the Validator Manager, Balancer Validator Manager contract. It's the only one I did on top of the teleporter one that I'm working on right now. So inheriting Validator Manager and Validator Manager and implementing this using the balancer side. So basically, this one has the same notion of security modules, that each of them has a max weight, basically. And so this way you can, as I was saying, you can set up, first of all, the POA security module that has 100%, but that has a max weight of 1,000, and then you can add another security module that can have up to, let's say, 25% of the weight. It's pretty hard to share some things like this, to be honest. I don't know what you wanted to see exactly.
Nothing. I was just looking for the code, actually.
Yeah.
Okay.
So this, maybe I can share this branch.
Yeah, we could just update the link in the ACP
Yeah.
as well. But definitely drop it in the chat if you can right now, just for our sake.
Yeah. This
Curiosity.
this one is the Balancer Validator Manager branch, where you can see.
Thanks. Are there any other open questions? I know that, one of those questions was, we don't like the word security module. I figure we can discuss that at the very end.
Yeah.
But if anyone else has any pressing comments, or even you, Gautier, if you really still have any aspects of this ACP that you're unsure of, like, I think the team is very interested in helping work through.
Yeah, well, as I was saying, I think I'm gonna just I think move toward referencing the teleporter implementation, and create maybe another ACP around the security model side and the balancer smart contract. Because I agree that, well, as things are right now, the way convert L1 takes change, etc. I mean, it makes more sense to have an upgradable contract of the Validator Manager, and
or we could go even deeper and maybe discuss a potential ACP to introduce a new P-chain transaction type that takes a warp message from an L1 to update the address of the validator management. That's,
I hear Steven loves coding P-chain changes.
he loves it. Yes, this will make Steven so happy.
So that's actually, it's a very easy transaction to add. I think that the two reasons why I think that wasn't included in ACP-77 was one, which it was originally. One, just because it wasn't quote unquote required, and we were trying to just have ACP be kind of the minimum set of changes required for introducing L1s, because it was already a massive ACP. So that's, that's irrelevant as far as like introducing a new ACP though. The more important thing is there were concerns about like notifying the new contract about like the state of that L1, like the validator manager. So like with the existing flow, when the contracts just get upgraded, like it already knows the full state of the validator set. It doesn't have to do anything special. But in the case that you're actually changing the entire like contract somewhere else, that new contract needs to somehow get what the current state of the L1's validator set is. And in some cases, it can be, perhaps even complicated, because the first contract might have like outstanding like messages that may or may not have already been delivered. So definitely not against that, but we definitely would have to like think through and make sure that it is useful. Specifically, the major thing that it unlocks if we do support a transaction like this on the P-chain is the switching of which chain owns the validator set. That's the one thing that is kind of not really supported right now, because if you're managing your own chain, you can do whatever you want on the contract basis if your validators are okay with it. But actually moving the ownership from one chain to another is a actual technical unlock. But yeah, I think the biggest question that we would have to answer is just like how the validator sets are synchronized, and like, is that useful?
So on this, so one use case I see, so we are for Suzaku right now, basically everything is gonna be on the C chain, like, because the stake cable tokens will be on the C chain, and probably the L1's contract will be on the C chain as well. And so yeah, it would be interesting to have this option maybe later on if the layer 1 wants to migrate to its own layer 1 at some point. Because I think, like starting on the C chain has some benefits when it comes to security at first, and then you can maybe move fully on your L1 once it's more mature and decentralized.
Yeah, I was gonna ask actually if there's any thing special about having the validator manager live on the C chain for a given L1, or not even just the C chain, but in general, another chain other than the chain that it's managing. We haven't, we knew that was a possibility, but that's definitely not what we had in mind when developing the contracts. I think we thought through it, and it should be totally possible to just deploy the contract on another chain, since you get to specify the subnet ID that it's managing the validator set of, but wasn't sure if, as far as restaking is concerned, that's definitely not something we were accounting for. So if there was other considerations there.
Yeah, but I know that some devs from my team have had some trouble making it work from the C chain because the tooling is not meant for this at all. So right now, but yeah, hopefully we can make it work.
Definitely would be interested in hearing what tooling didn't work. We can
No, because I think right now, well, one way to deploy the L1 is, or at least on DevNet, when it was on DevNet, like you deploy the L1 and the staking contract is already in there. The Validator Manager is already in the state of the L1, etc.
Gotcha.
Yeah, I think there was some messages mismatch, like in terms of the conversion data. But maybe eventually we'll make it work. I just that yeah, it doesn't have been like for one day, so right now we're still figuring it out. But yeah, hopefully.
Current version of the CLI is definitely for deploying the Validator Manager on the L1 that it's managing. So yeah, to that extent, doesn't support the C-chain case. Two things that we didn't touch upon yet that I just wanted to add, I think it's probably worth calling out in the ACP, which I think we both kind of have implicitly found, is one, for any proof of stake validator manager, the validator manager should live on the same chain where the asset is issued. Theoretically, you could bridge, say, AVAX or USDC or any other, your own ERC20 from the C chain into your L1, and then use that to stake on your L1. But specifically, if the rewards are issued in that asset also, then it gets very complicated to, you can't just mint on the bridged side. And then the other one was that you shouldn't use assets like USDC or AVAX where there's a large supply that you don't control as your proof of stake token for 100%, since that could be more easily taken over. I hadn't thought of including those in the ACP prior, but might make sense to call out. We did get a few questions on like, hey, can I bridge this token in and then use it as staking?
Yeah, that's definitely valid point. This is why also we're more looking into dual staking, so having both the layer one as well as a restaked asset, rather than having just a restaked asset, which is a bit more tricky to set up.
I was going to ask as well, with the validator set contracts being placed on the C chain for some additional security for small validator sets at launch, have you thought at all about strengthening warp signatures around that as well? There was a discussion that Michael started that I put a few ideas in around a sort of like a circuit breaker design, potentially using the same. Yeah. Have you thought about this at all for those early subnets or L1s? Sorry.
Yeah. So actually, this is something we put in the that we have plans to do, like in this Suzaku Relay network project that we have in standby right now. But it's like, I would have this notary, I think you call it, like this notary service. Yeah. But so as well, if you have the contract on the C chain, then you kind of like a bit less sensible to this, I guess. Or
Not really, because the warp message is still going to come from the subnet's validator set. So even though the C chain contract defines that validator set, whatever that validator set is still able to send a message because it's using the P chain's validator set, or the P chain replica of the validator set as the state of truth there. So you could still add an additional circuit breaker, or potentially whatever is in control of that validator set on the C chain, potentially routing it through some other chain as well to get an additional signature, or any kind of, whatever circuit breaker you want to define, of course, as well.
Okay, makes sense. Yeah. Actually, one thing I was wondering is, but actually it's not limited to the validator contract, but it's basically it's kind of unrelated to ACP. Like, what is the impact of now L1's not tracking the C chain anymore? Like when it comes to aggregating the signatures from the C chain to the layer one, because before it was done, I think, only on the validator set of the layer one. So you have like a few validators to query, whereas now you have to query the whole C. Well, not the whole, but like most of the C chain validator set.
Yeah, that's exactly what it is. Now you do have to the self-signing optimization for fully sovereign L1s is gone. So for messages from the C chain to the sovereign L1, permission or permissionless, if it's not validating the C chain, the primary network, then it needs a signature from the quorum of the source chain. In this case, C chain.
Yeah.
Did that end up being configurable where the EVM chain can decide whether it's using its own validator set as the source of truth for the primary network, or did we just go with it always uses?
There is a flag.
There's
there
a
is
flag.
a require primary network signers, but it's
Disabled by default. Cool.
Yeah. But actually, yeah, I think Aaron, I don't think I like understood all the concerns about this. Like the small data set part of things, because like if your data set manager is on the C chain, it's the C chain data set that well ensures that they would generate the weight change, the weight change message.
The C chain contract would, yes. So the
Yeah,
C chain contract would be responsible for making any of the weight changes, but for any other arbitrary warp message coming from, so for like any other arbitrary warp message, that could, you could have a circuit breaker on top of it, all those other messages coming from the subnet, which would be, that would probably be the type of thing you would want to add additional security to. At the same time, whenever you prefer to keep your validator set on the C chain, due to security concerns about warp messages coming from your subnet, that would probably also be the time where you might want additional security for the other warp messages coming from your subnet, right? Since it's the same time. So that would be where, like that kind of twilight zone, I guess you could call it, would be where additional security improvements to warp messages might be interesting. And that circuit breaker design might be interesting.
Yeah, makes sense.
All right, we have like 1 minute left, or it's actually 11:30 now. I do want to thank Gautier for coming on and presenting, and obviously for raising the ACP. Really super interesting conversation here today, and I'm looking forward to the update of this ACP or the potential proposal of any of the topics that we discussed here today. Thanks everybody for joining. And if you have any other questions or want to continue the conversation, feel free to post in the discussions thread for ACP-99 on the ACP GitHub. If there's any topic of keen interest, we can definitely hold another meeting. So just let us know. Alrighty, thanks. Have a good one.
Yeah, thanks, Megan. Thanks, everyone.